Hello guys, once again welcome to Lali's EduHub, and today we are going to do another easy tutorial, which is on spatial auto correlation. So GIS is becoming very interesting, and there are lots of tools in the ArcMap or the ArcGIS software that helps us to perform our spatial analysis in a very easy way without manually doing things. So for today, we are going to learn how to perform the spatial autocorrelation. So the spatial autocorrelation, what it does is it helps us to understand the degree to which one object is similar to other nearby objects. So what does this mean? Let's say you have a list of countries, or you have a list of hospitals, a list of schools, markets, or any geographic feature, and you want to understand the degree to which the objects are similar or they are closer to each other objects in your spatial environment, and we use the spatial autocorrelations to perform this statistical analysis. So as you know, in SPSS, sometimes for quantitative analysis, if you want to perform your analysis to find a degree, whether you want to support your um, null hypothesis or reject the null hypothesis, you know how it's been carried out in the SPSS. However, for GIS or geography, we use the ArcMap or the ArcGIS Pro or the MV or any software to perform the spatial autocorrelation um, analysis. So for today, we are going to start by uploading our files, and those files are going to be available in the comment section. So in case you want to download it, you can check the notification or the comment section to download um, the files. And if you want any information too, you can leave your message in the the comment section. I'll come back and read them and reply to your comments. And please make sure you do subscribe to the channel and learn exciting things. So let's get started. So for now, I have a survey feature I would like to upload. So this was a survey collected by students from the University of Ghana, Legon. So what the survey has is it has a list of schools, it has a list of hospitals, it has a list of lorry stations, and it has um, a list of markets. So all these dots you see here is they include some geographic feature. So what we are going to do is we are going to analyze and perform our spatial correlation feature to see the distribution or the degree to which the objects are similar to other nearby objects. So with this, let's make the data more um, appreciative. So we are going to do that by uploading our district or regional shapefile to see the exact region which these features are located. So I believe those features are located in Accra. Those of you who do not know Accra, Accra is located in Ghana, the capital town. So we are going to upload our feature. So I should have my feature somewhere here. So I'm going to upload my district or original files. So I have one here, new regions. So shapefile.shp. I'm going to upload it here, then I click on close. Yep. So as you can see, this is the original shapefile of Ghana, and as you can see, it has all the 16 regions, and the the data covers just this section of our map. So as you can see, this is the capital of the country, Ghana, and the data collected just covers this portion. So what we are going to do is we are going to work with this information we have here. Since we did not need the whole thing, we are only going to work with this information. So we are going to take away every feature here and just work with this. So to do that, there are two ways to do that. You have the selection, the two types of selection, but for now we are going to use select by attribute. So you come to your selection, select by attribute, then we select our new regions. So regions, we click on okay, then we use the equal to. So what this means is, I believe I explained it in the previous video. It means you are only going to look for features within this shape file or within this feature here, the region attributes. So we go to unique values and we look for Greater Accra, since that is what we are working with. So we double click and it's there. We click on apply, then okay. So the next thing is we like to take it off so we can just work with our region of interest. So to do that, you right click on your new regions and you come to data, export data. Then is you see your exports. We are all trying to export our selected feature. Then we can probably give it a name and a location. So I'm going to name my let's give it a name. So survey, let's just name it a survey. Okay, there's already a survey there, so let's do it Greater Accra. Greater Accra. So the file type is a shape file. We are not going to use the personal or geodatabase. We are going to be learning that um later. So for now we are working with just a shape file. So let's do it Greater Accra. Let's save it and we click on OK. So yes, do you want to add exported data to the map layer? We click on yes and it's there. So as you can see, it is there. So we can uncheck this ones, and as you can see, we only have our data here, our selected region, that is our region of interest, Accra. So this is the data we are going to work with. So as we saw earlier from our attributes table, the data contains lots and lots of information. So it has schools, markets, it has a whole lot of features. So for our studies today, we are only going to work with markets. So let's say we want to work with markets. So with the same process, you come to selection, select by attribute, since that is what we are trying to work with. And now we are going to use our survey data. We click on OK. Then we locate the feature attribute, feature, then are equal to, and we get our unique values. So from this data, we can get a lorry stations, markets, and schools. So for today, let's use markets. And it's there. We click on apply. And as you can see, the selected ones or the highlighted ones are the markets. And we click on OK. So that is it. So the same process, we can also export our markets data here by using the same procedure, selected features. So let's name it as market market. We click on OK, and it's there. Yes. So you can take off your survey, and as you can see, is these are all markets in the Greater Accra region. So you can view the label features, and you can see the attribute feature of what we have here. So we have Afienya Road market, we have the Dawanu market, we have the Tishi market, we have the Madina market, Pram Pram market, Nungwa market. We have a whole lot of markets here. So now the main work is we want to perform an autocorrelation on this geographic feature. So by this, we are trying to understand the degree to which one object is similar to another nearby object. So the degree at which the Chopoli market is similar or nearby this object or this market. So to do that, you can locate your Act2 box, you click, and you go to your Spatial Analyst 2. Sorry, we select the Spatial Statistic tool. So from your spatial statistic tool, then we come to analyze patterns. So we are trying to analyze the patterns between the features. Then we come to the spatial autocorrelation, that is Moran 1. We click on it and we input our feature. So one might be wondering, what is the Moran one? So the Moran's one is just a correlation coefficient that measures the overall spatial correlation to the data set. So it's going to perform everything here for us. It's going to perform the overall spatial autocorrelation for you. So it measures how one object is similar to other objects surrounding it. So as we discussed earlier. And then one thing you should know is if the objects are attracted to each other, then it means that the observations are not independent, and then the reverse is true. So we are going to perform it quickly. So it measures correlation based on feature location and attribute values using the global Moran 1 statistics. So you can also read a brief description from here, whether it is dispersed, is clustered, or um, yeah, all grouped together. So we are going to, so our input feature here, it's going to be our market or our service. So our input feature will be our service, and then our input field. So we are going to use the market data, since that is what we are trying to work with. So we go to the market and then our input field. So you can use the distance, you can use the near field. So we are going to use the distance t, and then make sure you click on generate report so that you get the statistical summary of what we'll be doing. So we leave everything as it is here, then you click on OK, and then you can wait for it to process here. So it's going to take some time to come. Yeah, so as you can see, it's running here. But if you also want to check for your success, you can come back to your geoprocessing, then you select results. We are coming to view the results of um, the spatial autocorrelation. So we click on results, and as you can see, it's it's a current session. So you click on the addition sign here, then you see the spatial autocorrelation. So it's come to give us an overview of what we are doing. So as you can see, it's done here. So yeah, so the spatial autocorrelation, as we said, it has a value ranging from -1 to +1, and then from a -1 means there's a perfect clustering of the similar values, and then when it is a 0, it means that there's no correlation or there's no autocorrelation. And then when you have a positive number, it means there's a perfect clustering of similar objects. So we have your index here, we have the z-score, and then we have your p-value. So what does it mean to get a positive spatial correlation? What does it mean to get a negative spatial correlation? And then what is the importance of the autocorrelation? So we are going to discuss all those things after getting our result. So we should also try to understand the z-score and then the p-value. So basically, the z-score is just what we have here. It is a numerical measurement that describes a values relationship to the mean of a group of values. So what the z-score does is it considers a very large sample size. Yeah, it considers a large sample size, and then the p-value, which is the probability value, is just a statistical measurement used to validate a hypothesis against the observed data. So whether if your probability value is greater or less than this, will you reject your hypothesis or fail to reject your hypothesis? That is what it also means. And also the p-value measures the probability of obtaining the observed result. So assuming that your null hypothesis is true, then assuming the null hypothesis is true, the lower the p-value, the greater the statistical significance of the observed difference. So as you can see, we have a lower probability value. So it means that our statistical significance is different. So in order to get the report, you click on the report file, you click on it, and it's going to generate it nicely for you here. So as you can see, we have your Moran index, and then we have your z-score, we have your p-value, that is it is interpreted here. We have your critical value, the significance value as well. So then the importance or the Moran 1 indexes, it measures the spatial autocorrelation. So Moran 1 can be classified as a positive, negative, and with no autocorrelation at all. So that is basically what we try to mean when we are talking about the Moran. Alright, so as discussed earlier, so given here, given the z-score of 1.1389, the pattern does not appear to be significantly different than random. So as you can see here, as z-score means here, the feature or the market features we have here, they are random. So they are not dispersed or they are not clustered. So from our data here, you could see that yes, they are random, they are not dispersed, or the distance from one object to the other is not too far, or the distance from one market to the other are not too close or compacted. So they are not clustered or grouped. So what it means is it's random. So as you can see from the statistics we have here, it's a random distribution. So assuming it were to be a dispersed distribution, you would see this here indicating probably a red, sorry, a blue data to show that it is dispersed. That is from 0.01 to less than -2.58. So these are the critical value score, the p value against the critical. So for the random, as we have here, is from the p-value. So we have negative 1.65 to 1.65. So this is how random the data we have here is. And then also for the clustered, if the market features were clustered, it would have showed here. The arrow would have been pointing directly here, meaning our p-value is greater than our critical value. So this is what it means. And then when it comes down, it gives you the Moran's index, the expected index, the variance, the z-score, the p-value. And then it gives you a data set of the information. So it has the input feature. What is our input feature class? Market. So in case you are trying to work with health facilities, it will come as health facilities. And in case you are working with hospitals, it will come as hospitals. In case you are working with schools, to come as schools. And then we also have the input field, that is the distance. And then we have the decline, and then what have you. So this is basically what the auto or the spatial autocorrelation means, and this is how to perform it using the ArcGIS or the ArcMap software. So this is just a general overview of spatial autocorrelation. So guys, thank you very much for watching today's session of Lali's EduHub, and I do hope you subscribe and share, comment your thoughts in the comment section below, and wait for more. See you guys in my next video. Bye.